Hey guys, how's it going? I made 3 contributions to Plexus-Utils aka Maven, and this video is about the second one. In the last video of my series about Plexus-Utils performance improvements, I explained to you how I am using new methods in JRE 7 to speed up the performance of reading and writing files completely that you have the content as a string. And meanwhile, we have more modern facilities provided by Java 11. So what I did in this second contribution was that I added specific code which is executed only when running on Java 11, and the base for that is a multi-release jar. If you are interested in how a multi-release jar is built, then check this video on my YouTube channel, which explains the details of that. I actually turned Plexus-Utils into a multi-release jars years back already. So this video only is about extending the multi-release jar by specific code for JRE 11. And to do that, I have added a profile, which you can see here, which is always active when building for JDK 11. So what it does simply is calling the Maven compiler with the target of making a new entry into the multi-release jar, which holds code from a specific folder, and the folder is Java 11. So source main Java 11 instead of source main Java. So that's the core idea, how you get a new JRE supported in a multi-release jar POM file. And what I actually wanted to do is that the file read and file write method, which I optimized in my last video, now is overwritten in a way that when running on Java 11 is using different code. So what we see here is that I only refactored the original code into an abstract base class. So the abstract base class holds the Java 7 code. So this code is explained in the old video, no need to dive into that. Now let's look into the calls. The file utils method actually is calling that code, and I modified it a bit. I removed the new file by path_get, which is simply done to get the calling code really jump into the method I actually have written newly. So there were different file read methods, and I want that not the file parameterized method is used, but the path parameterized method. So that has nothing to do with Java 11. This is just what I need to navigate to the method I wrote. So you see here there was a file read method already, and this was removed because we removed it into, or we refactored it into its own file. We have just seen that a minute before. This is also only the navigation code. You also see that the file write code was removed. It was refactored into its own class, and here comes a new base file utils class, and this one is located in the folder Java 11. So actually we have the same class twice. We removed the original methods from the original code, refactored it into the normal source main Java folder. So there is a base file utils that works with Java 7, and here is the same class inside of the source main Java 11 folder, and now it holds a different implementation of the exact same class, and the implementation is the trick that I want to show you. So whenever a file read is performed by the original calling code, then we jump here into this method which wants a path. So that's why I had to change the navigation code from file to path, because I want this one to work with paths. And what it does is that when we want to read the complete content of a file as a string, it simply calls the files.readString method. And the files.readString method is able to either work in an autonomous mode, so it takes the default encoding, or it's working in an explicit mode, so you have to pass the encoding. And you see here, I'm not passing the encoding as a string as in the Java 7 code. I'm passing a real charset object. And this method is internally optimized by the JRE, or can get further optimized later. It could be implemented in native code if you like. It works whatever it likes and whatever it makes run as fast as possible. So in the end, what we spare compared to the old code is the following. By the way, file write is done in a similar way, so it's not worth going into details. What we spare is the following. Let's go back to the old code. This is the old code in the new refactored file. And you see we have two code lines. The difference is that the Java 7 code is working with byte arrays. So when reading a file, I have to read a byte array, and then I have to manually turning the byte array into a string. And for that, there is no way to optimize it. I have lots of bytes in memory, and now I want to turn them into a string. So what I do is I give the bytes to the new string constructor, and that constructor builds an instance. There is nothing, no magic. The new method, since Java 11 does not work with byte arrays. So there is two improvements. First, internally, the JVM could, for example, have some magic technology how it turns the bytes into strings. And second, we have the optimization that I don't have to publish a byte array here. I actually don't even have to use a byte array. So there could be optimization inside that spares the byte array. Whether or not there is, this depends on the version of the JRE you have. So the more modern you have, the more optimized it might be. So we do not guess how it's working like. We just say it might be optimized in these ways. Actually, in modern JREs, there is such a magic optimization. For example, when we are using the new method, we do not manually create a new string object for every byte array, but there is internal data deduplication. Let's say it's data deduplication. So you don't have the same byte array copied for each string. So there is some kind of code deduplication going on. It's not perfect. It's not completely or 100%, but it's there. So it actually does not create a new string array holding all the bytes again and again. So in the end, Java 11 will be more efficient. It might not really be faster. Maybe it is, or it is not, but it is more efficient because it don't have to forward all the bytes into the user space just to create a new string for a possibly already existing byte array. So this is the optimization I've done. If you're interested in how the code deduplication works, check out the OpenJDK source code on GitHub. It's really not too hard to find and not too hard to understand, but it's not done by me, and my videos are about my work. So please check out that code and you will see what tricks the JRE actually does internally. So this allows us to benefit from that tricks. So far for today. I hope you liked the video. Please subscribe to my channel. Stay safe, and as always, party on.